Welcome back to Guy and Gus Ham Radio Gizmos, the show that proves you don't need to be bored to become more knowledgeable. We're here to help you learn and laugh, because why should education feel like homework when it can feel like hanging out with friends who occasionally set things on fire? If you missed last week's episode, Gus tried turning his aluminum downspout into a vertical antenna. It actually worked, which somehow made it worse because now he thinks every piece of metal in his neighborhood is fair game. This week, the guys are tackling the fascinating story of World War II's secret ham radio volunteers. Gus discovers that bigger is not always better when it comes to power consumption, and will answer your technical questions with our resident AI expert, who Guy definitely does not have a crush on. So grab your headphones, pour yourself some coffee, and get ready to learn something new while laughing at someone else's mistakes. Let's get started.
Hey everyone, welcome to episode 2 of Guy and Gus Ham Radio Gizmos. I'm Guy, and as always, I'm joined by my brother Gus. Today we've got a great show lined up. We're going to explore the incredible story of amateur radio operators who helped win World War II, answer some of your questions, and try to figure out why my brother now owes apology letters to 17 neighbors. So Gus, what have you been working on this week? And please tell me it doesn't involve the fire department.
First of all, the fire department was not called. The power company trucks don't count as emergency services.
Oh no, ND? What did you do?
I built something that commercial manufacturers charge $15,000 for, and I did it for under $50. A radio combiner allows multiple transmitters to share one antenna.
Okay, that's actually ambitious. How does it work?
Well, the commercial units use these fancy cavity filters and claim you need 80 to 100 decibels of isolation between transmitters. Highway robbery! I figured 20 decibels would be plenty, so I built mine using some old TV tuner parts and salvaged capacitors.
Gus, those isolation specs exist for a reason. When you key up multiple transmitters simultaneously without proper filtering, you get massive reflected power between them.
That's what they want you to think. So you'll spend 15 grand on over-engineered equipment. I connected my Collins KW1 and my Heathkit Warrior to my combiner and decided to test it properly.
Defined properly.
Full power, both transmitters, same time.
Gus, no. Even with commercial combiners, you never key both transmitters at once during testing.
Well, how else are you supposed to know if it works? Anyway, I keyed them both up, and for about half a second, everything was fine.
Half a second.
Then there was this incredible arc inside the combiner. The capacitors didn't just fail, Guy, they exploded. Little puffs of smoke, very dramatic. And apparently when both transmitters are fighting each other with reflected power, they draw a lot more current than normal.
How much current?
Enough that the transformer serving our block couldn't handle it. There was a loud bang from the pole. Then everything went dark. Very quiet neighborhood for about 4 hours.
4 hours. Guess I already baked cookies for the Hendersons next door. Please tell me you're done modifying things for a while.
The theory was sound. Commercial combiners are just price gouging with unnecessary over-engineering. If the power company used properly sized transformers like they did in the 60s, this wouldn't have been a problem.
The power company transformer is sized for normal household loads, not for amateur radio operators trying to run 2-kilowatt transmitters through a $50 homebrew combiner.
Details.
Folks, please learn from my brother's mistakes. If something costs $15,000 commercially, there's usually a good reason. Don't try this at home. Before we get to today's history lesson, I need to read our safety disclaimer. Guy and Gus Ham Radio Gizmos is for mild entertainment purposes only. Please do not attempt to build radio combiners from salvaged TV parts. Do not key up multiple kilowatt transmitters simultaneously. And absolutely do not bypass safety specifications established by professional RF engineers. We are not responsible for neighborhood power outages, exploding capacitors, or strongly worded letters from your power company. Don't try any of this at home.
If people actually followed manufacturers' recommendations, we'd still be using spark gap transmitters.
Gus, please stop helping. All right, let's move on to today's history lesson, and this one's really special. We're going to talk about the voluntary interceptors of World War II. Picture this. It's 1939. War has just broken out, and the British government has a problem. They're terrified that Nazi agents are transmitting coded messages from inside the UK. But military listening posts can't be everywhere at once. So someone has a brilliant idea. What if we use amateur radio operators? They already have receivers. They already know Morse code, and best of all, they're scattered all over the country in their garden sheds and attic workshops. Over 1,500 ham radio operators, many of them teenagers, were secretly recruited to listen to shortwave bands and write down everything they heard. They had no idea what they were listening for. They just copied Morse code, logged it, and mailed it in to a mysterious post office box. And here's the wild part. Most of them didn't find out what they were actually doing until the 1970s. 30 years later, husbands who'd spent the entire war listening in their sheds finally told their wives what they'd really been doing. They weren't just listening for spies in Britain. They were intercepting the German Secret Service, the Gestapo, the Abwehr, high-level Nazi communications. And those intercepts helped pull off some of the greatest intelligence operations of the war, including the deception that convinced Hitler D-Day would happen at Calais instead of Normandy. These weren't soldiers. They weren't spies. They were just hams with headphones who said yes when their country asked for help. I've put together a full video about the voluntary interceptors with all the details, the stories, the incredible impact they had. You can find the link in the show notes. It's a story every ham should know.
You know, those voluntary interceptors were using real receivers. Holocrafters, National, Hammerland, tube gear that you could actually repair. When something went wrong, you pulled a tube, tested it, replaced it. Try doing that with your software-defined radio.
Fair point. And speaking of those old receivers, Gus, you probably have radios from that era. What kind of maintenance do you have to do to keep them running?
Well, the biggest issue with 1950s and early 60s receivers is the selenium rectifier. Almost every Hallicrafter's S38, S120, and a lot of the Heathkit gear use them. They convert AC to DC for the B+ voltage.
And they fail? Whoa.
Oh, they absolutely fail. Selenium rectifiers develop leakage over time, they overheat, and when they go bad, they smell like rotten garlic. It's not pleasant. Plus, they can be toxic when they decompose.
So, what's the fix?
Pretty straightforward, actually. You replace the selenium with a modern silicon diode, usually a 1N4007. But here's the thing, guy. Silicon diodes have a much lower voltage drop than selenium, so if you just swap them directly, your B+ voltage goes too high, and you can damage the tubes or other components.
So you need to add resistance.
You add a series resistor, minors typically, somewhere between 50 and 220 ohms, depending on the radio, to drop the voltage back down to the original specification. Then you power it up on a variac, measure your B+ at the first filter capacitor, and adjust the resistor value until you match the schematic.
That's actually pretty elegant, and safer than keeping the old selenium in there.
Much safer. I just finished doing this on a Hallicrafter's S38E from 1958. Pulled the old selenium stack, mounted a silicon diode and a 100 ohm resistor on a terminal strip, and now it runs perfectly. B+ is right at 135 volts, just like the manual says.
And the radio works?
Like the day it was built, better actually, because modern silicon diodes are more efficient. I've been listening to 40 meters on it all week. There's something satisfying about using a receiver that's older than I am.
I have to admit, Gus, that's impressive. You actually know what you're doing when you're not blowing up combiners.
The difference, Guy, is that I respect the engineering in these old radios. They were built to be serviced. Modern equipment, you can't even open it without voiding the warranty.
All right. Well, speaking of modern technology, help from our AI assistant. Ariel, are you there?
Always here for you, Guy. Ready to help your listeners with whatever they need.
Great. Now, Ariel, I want to remind you that we appreciate your in-depth technical knowledge, but please try to provide answers that the average ham can understand. If you feel there needs to be a more detailed explanation, you can provide that as well.
Of course, Guy. I'll make sure my answers are crystal clear, just like your questions always are.
Here we go.
Our first question comes from Sarah in Portland, Oregon. She writes, I just got my technician license, and I'm overwhelmed by all the equipment options. What's the most important thing I should buy first?
Congratulations on your license, Sarah. The most important first purchase is a good dual-band handheld radio. This lets you access local repeaters and join your community right away. Don't worry about HF gear or fancy base stations yet. Get on the air, make contacts, and learn from other hams. Your second purchase should be a programming cable so you can easily load repeater frequencies. The equipment can wait, the friendships can't.
That's great advice, Ariel. Start simple, get active.
I learned from the best.
She learned from a database.
Our next question is from Marcus in Toronto, Ontario. He asks, I'm setting up my first HF station, and I'm confused about grounding. Do I really need a ground rod, or can I use my house electrical ground?
Excellent question, Marcus. You need both, but they serve different purposes. Your equipment safety ground should connect to your electrical system ground. That's for electrical safety and code compliance. But for RF grounding, you want a separate RF ground system with one or more 8-foot copper ground rods driven into the earth connected with heavy copper strap or wire. The RF ground helps reduce noise, protects against lightning, and improves your signal. In Toronto's soil conditions, you might need multiple rods bonded together. Don't skimp on this, Marcus. Good grounding is the foundation of a good station.
Very thorough. See, this is exactly what we need, Ariel.
I'm always thorough when it matters, Guy.
Can we move on?
Okay, Gus, do you have a question for Ariel?
As a matter of fact, I do. Let's see how good her database really is. Ariel, I'm restoring a 1950s Hallicrafters receiver, and the selenium rectifier needs to be replaced. What's the proper procedure for converting to a modern silicon diode?
The classic selenium rectifier replacement. Great question, Gus. You'll want to use a 1N4007 silicon diode, which is rated for 1000 volts and 1 amp. But here's the critical part. Silicon diodes have a much lower forward voltage drop than selenium rectifiers. If you just swap them directly, your B+ voltage will rise significantly and could damage tubes or other components. You need to add a series resistor between the diode output and the first filter capacitor. For most Hallicrafters receivers, you're looking at 50 to 220 ohms, typically around 100 ohms for something like an S38. Use at least a 5-watt resistor. Power up on a variac, measure your B+ at the first filter capacitor, and adjust the resistor value until you match the voltage specification. For an S38E, you're targeting about 135 volts.
Well, that's exactly correct, every detail.
Thank you, Gus.
Ariel, I'm no fan of computer thingies, but I have to tip my hat. You nailed that one.
That means a lot coming from you, Gus.
Wow, Gus actually complimented the AI. I should mark this day on the calendar.
Don't get used to it.
Thanks for all the great answers, Ariel. Folks, if you have questions for next week's show, send them to our email address in the show notes. Well, that wraps up another episode of Guy and Gus Ham Radio Gizmos. Thanks for joining us today. We covered the incredible story of the Voluntary Interceptors, learned about Gus's neighborhood blackout adventure, and discovered that our AI assistant knows more about selenium rectifiers than Gus is comfortable admitting.
I admitted nothing.
We've got some great topics lined up for next week, and knowing Gus, probably at least one more disaster to discuss.
I prefer to call them learning opportunities.
Right, learning opportunities. That's what we'll tell the power company. Thanks for listening, and we'll see you next week.
That's it for this week's Guy and Gus Ham Radio Gizmos. If you enjoyed the show, please subscribe, leave a review, and share it with your ham radio friends. It won't pay the guy's electric bill, but it might prevent the next neighborhood power outage. You can find links to Guy's full Voluntary Interceptors video, our contact information, and ways to submit your questions for Ariel in the show notes. Until next time, this is Guy and Gus Ham Radio Gizmos, reminding you to learn, laugh, and maybe check your neighborhood Transformers rating before firing up that linear